Hi, I'm Eitan Medina, Chief Operating Officer of Habana Labs, and I'm excited to show you that Habana and Intel are all in on deep learning accelerators for AI. In fact, we are so all in that we are pleased to present to you our second generation processors for deep learning training and inference. We will also show how some of our customers are using Gaudi to reduce costs and accelerate their time to market. And finally, I'll discuss some of the work we are doing with our ecosystem partners to help you, our end customers, take advantage of those innovative solutions. First, let's understand how Habana fits into Intel's overall AI solutions portfolio. AI is the fastest growing application in the data center and the cloud. But the reality is that enterprise customers have different combination of applications for different servers. So Intel's portfolio of solutions is built to offer the most efficient solution for different uses. For servers where the AI compute is a small portion of the overall workload mix, or where the data pre-processing is central, Xeon is the best solution in a CPU-only server. For a mix of AI, HPC, and graphics in the same server, a server built with a CPU plus GPU accelerators is the best. But if your server's main function is doing deep learning compute, the most efficient solution is a CPU plus dedicated deep learning accelerator, and that is Intel's best solution for deep learning. Deep learning is critically important for decision makers planning their compute requirements for the future data center. The data center accelerator market was valued at $14 billion in 2021 and is anticipated to reach $65 billion by 2026. We are witnessing a growing surge of customers uploading data to the cloud and driving the demand for cloud storage and compute capacity for deep learning. The surge in training models and deploying them has led to a surge in accelerator demand. By 2026, a third of all servers shipped will run deep learning. And model training will dominate what you use your servers for in the cloud and on-prem. Our job is to provide you with the best acceleration possible. Today we are pleased to announce the availability of Gaudi 2 to our customers, starting now. With a huge leap in process node from 60 nanometer to 7 nanometer, we took the very efficient Gaudi 1 architecture and packed a huge performance boost into Gaudi 2. The MME and TPC compute clusters are much more powerful. Instead of 8 TPCs, we have 24 TPCs that were upgraded internally with additional functions. We added several new data types, including the FP8, that can help both accelerate training models and utilize the memory more efficiently. On top of that, we included an independent media engine so Gaudi 2 can take in compressed media directly. So we free up valuable CPU cores inside the server and balance the overall performance. Gaudi 2 is the first and only accelerator that supports 96 GB of HBM2 memory, so you get much larger memory support than Gaudi 1 and 2.5x on memory bandwidth. This way, the increase in compute is well balanced with increase in memory capabilities. While our first generation integrated 10 Rocky RDMA NICs on chip, Gaudi 2 integrates a whopping 24 100 gigabit Rocky RDMA NICs. This amazing native integration of networking on Gaudi 2 has several benefits for our end customers, who compared with GPU-based solutions will need much less components in their servers and avoid making PCIe a bottleneck while avoiding locking themselves to proprietary interfaces in their servers and cluster designs. Finally, we were able to deliver Gaudi 2 with a TDP power of 600 watt that is implemented with a standard passive cooling solution. This means you can build and deploy Gaudi 2-based servers without requiring liquid cooling in your data center. Now, you're probably wondering how all these capabilities translate to real-world performance with the full software stack in actual deep learning workloads. After all, that is what matters to the end users, right? So, let's start with a quick demo on an actual Gaudi 2 server. In our lab, we have a live Gaudi 2 server that we control from here. Let's kick off the training run. We just started compiling the standard ResNet 50 model for training using a single Gaudi 2. End customers want to train more and pay less, so they care about two things: the cost of using the server and the time needed to train their models. The training time depends on the amount of data needed to achieve the target model accuracy. The key factor is the speed or throughput at which the accelerator can process data. The higher the throughput, the faster we can train. The logs being printed on this screen show the live progress of the model accuracy and the actual throughput in every iteration of data. To help visualize the progress, we have on the left an active TensorBoard screen. You can see that Gaudi 2 has reached the steady-state throughput of almost 5,500 images per second. So let's compare to NVIDIA's leading shipping solution today, the A100 GPU. While Gaudi 2 is implemented in the same 7nm process as the A100, it delivers approximately twice the throughput of the A100 GPU. We measured here the out-of-the-box performance that end customers see when they take official framework containers from NGC and run the workloads with the recommended parameters by the vendor for best performance. We also included here Gaudi 1, which thanks to its efficiency and lower system cost is able to deliver 40% better price performance versus the A100-based instances. As you can see here, Gaudi 2 more than tripled the Gaudi 1 throughput in this workload and shows clear leadership over the A100 GPU. The higher 96 GB memory means that topologies that do not fit GPUs could potentially fit Gaudi 2, which would help in both performance and TCO. An accelerator designed from the ground up in the same process node and similar die size is delivering approximately twice the throughput of the leading shipping GPU today. That is why deep learning server should be based on the Gaudi architecture. For evaluating the performance for natural language processing models, let's check out the throughput for BERT, the most popular language model. We are comparing here the actual throughput for BERT Phase 1 and Phase 2 under TensorFlow. We measured it on official NGC Docker containers with the recommended optimizers and parameters for highest throughput, exactly as an end user would do when they train on either cloud instances like AWS or Azure or on high-end DGX machines. As you can see, a single Gaudi 2 throughput outperforms an 80 gig A100 by a factor of 1.7 in Phase 1 and a factor of 2.8 in Phase 2. And if you're wondering what is the effective throughput for the complete BERT training, twice the throughput versus the A100 80 gig, 2.7x versus the 40 gig A100, and over 5x versus the V100. So we have shown you that a Gaudi 2 card delivers about twice the throughput of A100 on two of the most popular vision and language models. We already deployed 1,000 Gaudi 2s in our R&D data centers, and Gaudi 2 is available for our customers. To show you how you scale using Gaudi 2, let's have a look inside the server we use the HLS Gaudi 2.
Scalability of deep learning AI systems is increasingly important as compute demands grow. Networking with Gaudi 2 is based on the innovative Gen 1 Gaudi architecture, but brings even greater capacity and configuration flexibility to the AI data center. Here's how. Habana's second-generation Gaudi 2 advances AI networking with another first. It's the only processor to integrate 24 100 gigabit RDMA over converged Ethernet or RoCE ports on chip. That's an increase from 10 100 gigabit Ethernet ports on the original generation Gaudi to 24. The HLS Gaudi 2 server features 8 mezzanine cards and integrates 2 dual-socket Intel Xeon Ice Lake CPUs. The 8 Gaudi 2 cards connect in an all-to-all configuration with 21 ports of each Gaudi dedicated to connecting to the other 7 cards in the server. The remaining 3 100 gigabit Ethernet ports per Gaudi, or 24 100 gigabit Ethernet per server, are dedicated to scaling out through 6 400 gigabit QSFP DD ports. For workloads that require more than 8 Gaudi 2s, you can scale out system capacity by connecting each Gaudi 2 HLS system to standard Ethernet switching of your choice, using up to 6 400 gigabit Ethernet cables. And, as you can see in this Gaudi 2 8-node cluster, you can scale out more capacity across more racks. For larger deep learning compute demands, multiple clusters can be easily and cost-efficiently networked via standard Ethernet switching and scale out as far as you need. The Gaudi 2 data center you see here was built to conduct R&D at scale to inform hardware and software development. We're applying learnings from this data center to further optimize Habana's software stack and Gaudi 3 development. Why? Because at Habana, we're all in on AI. Habana Labs.
End customers are already leveraging our first-generation Gaudi in both the AWS cloud and on-prem. Both the Amazon DL1 instance and the Supermicro X12 server include 8 Gaudi accelerators with a dual-socket Xeon subsystem. Customers can therefore leverage Gaudi 1's efficiency on-prem and in the cloud, with a native support from converged MLOps software for both. These customers were motivated to use our first-generation Gaudi for training thanks to its incredible efficiency compared to GPU solutions. The best way to compare is to do it exactly as end users do, namely, with the official framework Docker containers provided on NGC for NVIDIA and for Gaudi on Habana's developer cloud repositories. A key factor to the training time convergence to the target accuracy is the speed or throughput that the accelerator is able to process the data. The higher the throughput, the lower the training time. The second factor is the cost of using the server, where the accelerator cost is a big part of the server cost. Price-performance ratio is what matters most, and these graphs show the key motivation for customers using GPUs to try DL1 in the AWS EC2 cloud. As you can see, for ResNet 50 and BERT, which are 2 of the most popular models for vision and language, under TensorFlow, the Gaudi instance offers around 40% cost savings versus the A100-based instance and about 60% versus the V100-based instance. Our Synapse AI software stack provides our customers the support for training on Gaudi with minimal code changes. The software comes integrated with TensorFlow and PyTorch and includes a rich library of performance-optimized kernels. The majority of deep learning users are working in Python and do not go below the framework level. But for those advanced users who want to create custom kernels, we have all the tools needed to augment our libraries with their custom kernels. On our developer site and GitHub, we provide open access to everything needed to use Gaudi. We spoke about the motivation to use Gaudi 1, train more and pay less. With Gaudi 2, that motivation would be both price performance and absolute performance leadership. But what most of our engineers are really focused on is lowering the barriers to adoption and making it as easy as possible for you to use Gaudi in building new models and migrating models you run today on GPUs. Take a look at our developer.habana.ai site and our GitHub and check out the documentation, the software, the tools, the reference models, and the how-to content. It is all open, and we are eager to interact with the community directly to get your feedback and improve. Our software is continuously upgraded with our reference models expanding all the time. Developers are picking up reference models from our GitHub and immediately implementing common use cases such as object detection, semantic segmentation, image classification, and natural language processing. This usage spans multiple industry segments and applications, from manufacturing to medical to mobility to e-commerce, where these models, families, or combination of models are continuously being developed. Getting started with Gaudi is as simple as adding 2 lines of code, as you see in this example. You load the Habana module and simply run using the software container. Since we launched Gaudi last year, we were busy working with multiple customers in showing them what is possible with Gaudi and helping them with their journey. Today, I'd like to share with you what some of them were willing to share publicly. As a world leader in automotive and driving assistance systems, training cutting-edge deep learning models for tasks such as object detection and segmentation that enable vehicles to sense and understand its surrounding is mission critical to Mobileye. The key for Mobileye as other customers is to see that the benefits we show on standard reference models translate also to their custom models, and that migrating them from GPUs to Gaudi is simple. As you can see, one of the lead researchers confirmed that we met and actually exceeded the 40% price performance mark. And this is not just a singular case where one engineer tries something. Right now, as their head of R&D confirms, we have multiple teams across Mobileye using Gaudi in their production environment across several families of models. The benefits they realize with Gaudi are not just cost savings, but also accelerated time to market for deploying models, and these benefits are enabling them with much larger and more complex models they now develop using Gaudi. If this is what they see with Gaudi 1, just imagine what will Gaudi 2 do for them. Leidos is a leading provider of AI solutions for many US agencies. They have verified that the Gaudi-based DL1 instance delivers 60% cost savings when using a deep learning model for detecting COVID-19 in X-ray images. They confirm that fast and efficient deep learning is critical for customers they serve in health and life sciences. Reducing cost of AI means these organizations will be able to move faster in diagnosing and finding cures for diseases. In early April, the Voyager supercomputer at San Diego Supercomputing Center successfully passed the NSF review and is now open to the research community. This is the first supercomputer that took full advantage of the unique integration of RoCE networking on our Gaudi processors. The Supermicro server you see here scales out using 24 100 gigabit Ethernet RoCE NICs that are directly connected to an Ethernet switch in this supercomputer cluster. The native integration of RoCE on the Gaudi chip eliminates bottlenecks you see today with GPU architectures and does it at low cost. Researchers are using Voyager to work on a variety of applications. It's actually amazing to see the unique applications making use of deep learning. A cool example here is UNet and CNN models that are being trained on Voyager's Gaudi processors for segmentation and classification, so researchers can find better ways to manage wildfires. Working with the ecosystem is critically important to enable our end users to easily leverage Gaudi's benefits. developers are embracing the wider ecosystem tools, model libraries, and additional frameworks developed by the community at large. As the industry finds ways to develop even higher levels of abstraction, our job is to simply fit in with an ever more efficient back-end, while the front-end is standard, open, and evolving independently of which hardware is underneath. Grid.ai and PyTorch Lightning makes coding neural networks simple. Habana Gaudi makes it cost-efficient to train those models. The integration of Habana's Synapse AI software suite with PyTorch Lightning brings the best of both worlds together, enabling greater developer productivity while lowering the cost of model training. PyTorch Lightning 1.6 was recently released and now supports Habana Gaudi. With millions of monthly visits, Hugging Face is one of the fastest growing projects in open source software history, and the go-to place for the machine learning community. The partnership we announced last month means that with the integration of Habana's Synapse AI software suite with the Hugging Face Optimum open source library, data scientists and machine learning engineers can now accelerate their transformer model training on Gaudi processors with minimal code changes. Converge.io MLOps software is the best machine learning operations solutions out there. Today, you can use MLOps to increase productivity in using Gaudi both on-prem and in the cloud. Whether you are an ML engineer, DevOps, or IT users, the Converge MLOps software will help you utilize your compute resources more efficiently as part of your end-to-end deep learning pipeline. So, as our software stack comes together, you can use Supermicro Gaudi servers on-prem or burst training jobs to the DL1 on AWS EC2 cloud, flexibly and seamlessly. On top of announcing the availability of Gaudi 2 for our customers, we are introducing also Greco, our upcoming second generation 7nm inference processor. We already deployed our first generation Goya inference accelerators with several customers who use high density inference acceleration at scale in their own data centers. While Goya was implemented in 16nm, Greco uses the 7nm process, which allows us to increase performance, reduce power, and optimize its form factor. With 16 GB of LPDDR5 memories, we provide 5x more memory bandwidth relative to Goya, and we are boosting the on-chip SRAM from 50 to 128 MB. These help in boosting inference performance across all model types. Greco adds new data types such as 16-bit floats and 4-bit integer, and integrates an independent media engine for dealing with compressed media natively, so that the host CPU will not become a bottleneck with this level of AI acceleration in the server. While Goya was implemented in a dual-slot form factor, Greco is implemented in a compact single-slot card, which allows our customers to double the density of cards in the same server. And finally, Greco is implemented with a TDP of 75 watts, so you get high-performance inferencing in a much lower power, so that we improve the price performance and power performance in the same time and at the system level. The compact form factor of Greco also means that you can drop in and replace GPU cards with Greco in existing servers. Greco will be available for select customers later this year. Deep learning is key to all of us. Our singular focus is on delivering to you the best accelerators possible, designed from the ground up for efficiency, ease of use, and scale. Thank you.